All right, guys, we're going to talk about scientific investigations and the scientific method in general today. We're only going to talk about the first two steps of it. The question and the hypothesis, the first two steps. Science tries to answer questions about how the world works. We try to uncover the rules or the laws of nature by doing tests to see how things react when something's done to them. By seeing how they react, we learn things about the world and the universe that we live in. So in a scientific investigation, the question guides our investigation. Okay? Question guides our investigation by keeping us focused on what we really want to know. Now, I'm putting the quotations up because your worksheet has kind of things to fill out on there. The cool thing about this is that if you need time to type or anything, you can just pause the video and finish typing in what you need to type, or you can listen to it through and then go back and try to answer the questions. Whatever way you want to do it. It's cool by me. So the question guides our investigation by keeping us focused on what's really important. What do we really want to know about it? So we'll get into the hypothesis next. That's the next step. The hypothesis comes from the question, and you can pull it right out of the question. And from that, you're going to get a lot of things for the investigation. You'll get your variables and things from it. So, number one thing, the hypothesis is a prediction for the answer to the question. Okay? It's what you think is going to happen. Okay, in answering your question, it's your idea. Usually it's based on some kind of former knowledge or idea that you have. Whether you're right or wrong doesn't matter. The thing is the question and the test, that's what matters. It is not a question. It is a statement. It is a prediction. It isn't, I guess, no, it is a statement. So that's the way you want to go. The hypothesis must also be testable. If it's not testable, it's not science. If you can't test it, not science. It needs to be testable. The hypothesis predicts how you think the experiment is going to turn out. Okay, it's what you think is going to happen in your prediction. So if we use something, say we have a question about how do ramps affect how a ball rolls down the ramp. We have that question, we could come up with a hypothesis. And the hypothesis might be, as I raise the ramp angle, the ball will roll faster down the ramp. That's a prediction. That's not a question, it's a prediction. So you're kind of saying how you think it's going to turn out. And the hypothesis comes directly from the question. The most effective hypothesis, especially for 8th grade level, is if we put it in an if-then statement, okay? If you put it in that way, when it's done that way, the variables are easy to identify. Okay, they're very easy to identify. The variable that causes the change is called the independent variable. So if we set up our hypothesis, if I change the angle of a ramp, then the ball will roll faster. Or if I increase the angle of the ramp, the ball will roll faster. That is a good hypothesis. The independent variable is the if statement there. If I raise the angle of the ramp, okay, that's something you're doing. You're changing it on your own. You're changing the angle of the ramp. If I raise the angle of the ramp, the ball will roll faster. We get it right from the question and right from the hypothesis. We have our independent variable. It's in the if part of that statement. So the independent variable is what the scientist chooses to change to see what happens, and you get it from the question. So the second part, the then statement, becomes the dependent variable. It's how we expect changing the independent variable is going to affect the outcome of our experiment. Okay, so the effect you are looking for is called the dependent variable. The dependent variable is that variable that the scientists are looking to measure in the experiment. Okay, you're going to measure the speed of the car, or how fast, the time it takes the car to get to the bottom. That's what we're going to do. So how the dependent variable changes tells us if our hypothesis or our prediction was correct or not. So we have if the angle of a ramp changes, then as the angle of the ramp increases, then the ball will roll faster. We go through, we have our independent variable, changing the ramp angle, increasing the ramp angle, and our dependent variable, how fast or the speed of the ball down the ramp, that will do it. If we did that experiment, which I've done before, we would find that as the angle of the ramp increases, the speed of the ball increases as well, and the prediction would be verified. Okay, we would be correct. If we're not correct, that's even more useful because now we can learn something about it that we didn't know before. We thought we understood it. We would have if we did understand it, we'd have a correct answer, correct hypothesis. If there was something we didn't understand, now we can learn. That's why incorrect hypotheses are just as useful or even more useful than correct hypothesis. You can complete the rest of the sheet. You can come back to this video if you're having trouble understanding what an independent or dependent variable is. You have further questions to do, and you can submit this through Google Classroom. Thanks for listening.